Okay, so today we're going to talk about functions, and to find the value for a function for a certain number, you're going to substitute a number for the variable x. So, as we have talked about before, the output is the range. Remember the domain and range before? The domain was the x value, the range was the y value. And the input is your domain, which is your x value. Okay? This is another kind of notation that's used with these functions. Okay, so in number one, they're asking you to plug in, we say f of negative 3 for the function f of x is equal to 2x plus 1. So we're going to plug negative 3 where there are x's. Then we solve. 2 times negative 3 is negative 6, plus 1 is negative 5. So what that's telling you is if you were to graph this line, and I'm going to take this line right here and graph it, my y-intercept is 1, my slope is 2 over 1, so I'll count up 2, run 1, and there's my line. Okay? Now what we just did is where is, if x is negative 3, what is y? So at negative 3, f of negative 3, 1, 2, 3, we are seeing that our y is at negative 5. Right there. So no matter what number you put into x, it's going to be, you're going to get a y that is a point, an x and a y that's on that line. So now let's try finding the function value for f of 2. So we're going to plug the 2 in, and we get that f of 2 is negative 2. So for a, f of 2 is negative 2. Okay? And if we try it for this one, we get f of 11 equals 1/2 times 11 plus 5. So f of 11 is 11 over 2 plus 5. 11 over 2 is 5.5. 5.5 plus 5 is 10.5. So once again, if we were to graph the point 11 on this line, x is equal to 11, the y-coordinate will be 10.5 where that point falls on the line. So like we've talked about before, we have a domain and a range when we're dealing with linear equations. The domain is the independent variable, your x, and the range is the dependent variable, your y. And it depends on the domain. So the range depends on the domain. For number 2, we have f of x is equal to x plus 5. And we're going to make a table, a function table, to be able to figure out what the range is given a domain right here. So we plug those numbers into the rule, and we get these outputs. Okay? So then we have our domain and our range. Our domain is our x values, and our range are our y values. So now on C, they're asking you to choose 4 values for x to complete the function table for f of x is equal to x minus 7. So for x, you can choose any numbers you want to. You can even choose 0. So let's choose 0, 1, 2, 3. It's best to use small numbers because they're more practical. And if you have a fraction in the equation, you might want to use multiples of the denominator so that they cancel out. But I'll show you that later. So we're going to put 0 minus 7, negative 7. 1 minus 7, negative 6. 2 minus 7, negative 5. And 3 minus 7, negative 4. And they ask you to state the domain and the range. So the domain is 0, 1, 2, 3. And the range is negative 7, negative 6, negative 5, negative 4. Okay, so now we're going to look at peanuts. And according to this problem, 777 peanuts are in a jar of peanut butter. And the total number of peanuts, P of J, is a function of the number of jars purchased, J. So J is your independent variable, and P of J depends on how many jars there are. So that's why it's the dependent variable. Okay? So to identify the independent and dependent variable, the total number of peanuts depends on the number of jars. Okay? Which is P of J. Which is the dependent variable, and the jars of peanut butter is the independent variable. Okay? P of J, how many peanuts there are going to be, depends on how many jars, right? Okay, so now they say what values of the domain and range make sense for this situation. Of course, you're not going to be able to go to the store and buy a jar of peanut butter that's half full. So what makes sense is whole numbers. So we're going to choose whole numbers if we're going to create a table of values for the jars of peanut butter. Now here they're asking for, hold on a second. How many peanuts would be in 7 jars of peanut butter? So we're going to take our dependent variable, P of J, is equal to 770 peanuts per jar. Okay? So when we put 7 in there, we get 5,390 peanuts. So if we look at f of 4 for the function f of x is equal to x minus 6, we're going to plug in 4 for x, and that equals negative 2. Then it says to choose 4 values of x to make the function table for f of x is equal to 8 minus x. So, as I said before, it's good to choose small numbers. And we plug them into the equation, and we find out what our range is. So 8 minus 1 is 7, 8 minus 2, 6, 8 minus 3, 5. It asks to state the domain and range. The domain are our x values. And you should use the notation that I'm using. And the range is 8, 7, 6, and 5. A hot air balloon can hold 90,000 cubic feet of air. It's being inflated at a rate of 6,000 cubic feet per minute. The total cubic feet, which is your independent variable, is a function of the time, which is your independent variable. Okay, so for the hot air balloon that can hold 90,000 cubic feet of air, the total cubic feet is your dependent variable, which is a function of the time in minutes, which is your independent variable. Okay, so independent is time. Depends on how much time is going to depend on the total cubic feet. when you're inflating the balloon. And the total cubic feet is your dependent variable because it just depends on the amount of time. The values of the domain and the range that make sense for the situation, well, it has to be less than 90,000 because that balloon will only hold 90,000 or less. But you can't have negative cubic feet of air, right? So it's going to be between 0, the domain, domain and range is between 0 and 90,000 because that's the capacity of the balloon. Finally, C says to write a function to represent the total amount of air, which is f of x, actually I'm going to do t, f of t equals the rate of 6,000 cubic feet times time, because it does it per minute. And then it asks us to determine the total amount of air in 6 minutes. So we'll do f of 6 is equal to 6,000 times 6 is 36,000 cubic feet. Cubic feet per minute. Oh.